Okay, today we're going to go over percents and absolute value, and you will be hearing from me, your well-rounded math teacher, Mr. Picard. To start out with, to find percents given a fraction, divide the numerator by the denominator. So if you look at this problem down here, number 1, if you receive 21 out of 24 on your last quiz, what percent of the questions did you answer correctly? You'd take the numerator, top number, 21, and divide it by the denominator, the bottom number, and you'd get some decimal. The decimal in this case is 0.875. Now, that's the decimal equivalent. You want your percent. In order to get your percent, which is per 100, you have to move your decimal place 2 places. This would be the tenths, hundredths. So it's actually 87.5%. If you wanted to round it to the nearest percent, you'd basically get rid of your decimal. Looking at your 7 here, you'd look at the 5 behind it. That means you round up, so it'd be 88%. But usually, I like your answers like this, 87.5%. The 5 is in the tenths position, so that's the nearest tenth of a percent. So usually, it's either the nearest percent, which would be 88%, or just like we have here, rounding to the nearest tenth of a percent, 87.5%. So basically 1 decimal place behind your 1 decimal place behind your percentage. Okay. To find a percent given a decimal, a couple ways. Move the decimal place 2 places to the right. So basically, we're looking down here. 0.0235 is a decimal. You want to write it as a percent. You move your decimal place 2 places. 1, 2. So you end up with 2.35%. Now, if I wanted to round that to the nearest tenth, you could leave your answer like this and it would be fine, but I kind of like you to round it to the nearest tenth of a percent. It's a nice, clean way to write it. There's the 3 in the tenths position. You look behind it, see the 5, so it tells us to round up, so this is 2.4%. If you left your answer like this, that would also be fine. Some people don't understand why you move it 2 places. So here's another way to look at it. Whenever you want to change a decimal to a percent, you're multiplying by 100. So multiply the decimal by 100 to change it to a percent. If you take 0.0235 and multiply it by 100, what you're going to get is 2.35, which is the same thing as what we have down here. So either move it 2 places to the right or just multiply it by 100, which is moving it 2 places to the right, whichever works best for you. Another way to work with percent problems is this: is over of equals percent over 100. This is called the percent proportion. You can see down here what percent is, for number 3 here, what percent is 45 of 78. You can plug these 2 numbers into the percent proportion up here. Is like your part. It's part of the whole. Well, what is the whole? 78 is the whole. It's like saying, I got 45 right out of 78 on a test. If you got the whole test right, you would have got 78 out of 78. But in this case, we only got 45, the part of 78. So if I was going to plug these into the percent proportion up here, I'd say is 45. I'd put that in for my is. Of 78, I'm going to plug that in for the of. Equals percent. We don't know what the percent is. We're trying to find the percent. So that's going to be my variable x all over 100. And then solve this like you would solve any other percent proportion, or proportion for that matter. Multiply these two, 45 times 100, and then divide it by the other number that's given, 75. And that'll give you your answer for x. In this case, it is 57 point. If you round it to the nearest tenth of a percent, 57.7%. The answer to number 4, I'll let you guys try that and set it up, is I get about 39 point, we'll say 1 So I'll let you try that one. For number 5 here, I'll set it up for you. 12 is 15% of what number? Here's the deal. Of what number? We don't have the of. We do have our percent in this case, and the 12 is our is or our part. So if I set up my percent proportion, is over of equals percent over 100. 12 is my is. 12 is what? Of what number? We don't have the number, the whole. So I'm going to put an X there. I know my percent is 15%. You just put the 15. You don't have to put 15% or change it to a decimal because you're dividing it by 100. That changes it to the decimal for us. So now we solve for X. So basically 12 times 100. And then you're dividing by this other number, 15. And that's going to give us X. And X in this case is going to equal 80. 80. So basically 12 of 80 is 15%. Okay. Percent of increase or decrease. We're going to use this when we want to figure out, like, we have 10 people in the class today. Tomorrow we have 13. What was the percent of increase in people? You're going to use this quite a bit this year. So, and the formula for it is this. Difference in the two amounts compared to the original amount. So that's what you have to decipher from your problems. So we're going to do this first problem here. The number of students at Franklin High School increased, so we're looking for percent of increase, from 840 to 910 over a 5-year period. What was the percent of increase? So first of all, we got to find the difference. The difference between these two is basically you just take the higher number, whichever one it is, 910 minus 840. 910 minus 840 is 70. So this is my difference in amounts. The original amount is this, the amount you started with. It's not always going to be the larger number. Franklin High School increased from 840. So 840 is the original amount. So when I set this problem up, it's basically difference in amounts, 70, all over the original, which is 840. Divide these two, change them to a decimal, and then change them to a percent. You end up with 0.0833. So this is my decimal amount. Now changing it to a percent, I move my decimal 2 times, and I end up with 8 point, if we're going to round it to the nearest tenth of a percent, 8.3%. I'll let you guys try number 8. You should get 13.75%, which is a very good answer, or if you round it to the nearest tenth of a percent, 13.8%. Either one of those is fine. Okay. Time to go shopping. This is where you're really going to apply some of what you learned. You guys have done this before. I know you've done this before. Time to go shopping. Here it is. An umbrella costs $14. But you get a discount of 20%, which is good, so it's not going to cost quite $14. It's going to cost less than $14. But then you have tax, which if you look at it this way is bad because it's going to increase the cost of the umbrella. So there's a couple different ways to do this. I'm going to show you the way I do this. I use shortcuts. First of all, if I was going to pay 100% of the cost, I would pay this $14. But I'm taking 20% off. So I'm going to subtract this 20% from 100%, and that's left with 80%. So really, I only have to pay 80% of the $14 here. Excuse me. When you want to find 14%, I'm sorry, 80% of a number, this number being 14, you multiply. 14 times Now here's the deal. 80% is actually move the decimal back now because you have to change it to a decimal. 0.8. Moving it twice, you get 0.8 or 0.80. 14 times 0.8 is going to give us 1120. Okay, so if there was no tax, this is what I'd pay, $11.20. But I do have tax. Tax is actually 6%. If I change that to a decimal, it'd be 0.06. So as a decimal, it's 0.06. I want to find 6% of 1120. So I'm going to multiply it by 0.06. Okay, and then you would take that amount, whatever the tax is, and subtract it, or I'm sorry, add it to $11.20. A shortcut for doing this is this. Add a 1 here, because what it's doing is multiplying 1 times 1120, which is 1120. And the 0.06 times 1120 is going to give you your tax amount. You add those two together, there's the tax, and you get your answer. This basically does it all for you in one shot. So if I multiply these two, I get 11.872. Well, we got to round to the nearest cent. This is 80 cents. This is 7 cents. It's 87 cents. You can round to the second decimal place always when working with money. And we see the 2 back here, so we round down. It just becomes $11.87. 11.87. Okay. Now, yes, there is other ways to do this, and you can do it whatever way you want as long as you get the right answer. This one over here is $52.19. So you can go ahead and try that one and see if you get it right. Okay, we're getting into absolute value. The absolute value of a number is the distance away from 0 on the number line. So if I want to find the absolute value of -3, the symbol for absolute value is 2 bars like this. If you look at the number line, there's 0. There's -1, there's -2, and there's -3. Well, what's this distance right here? 1, 2, 3 units. Distance is always positive. So the absolute value of -3 is 3. So working with some absolute value problems. Just evaluating them. And you can see here that the absolute value of 7 is 7, and the absolute value of -7 is 7. So whenever you take the absolute value of a number, you're just taking its positive equivalent. When you are evaluating, though, you have to look at the absolute value symbol right here, like grouping symbols. Or parentheses. You have to do everything inside there first, then take the absolute value of it and get your final answer. Okay, so let's evaluate this problem, doing what's inside the absolute value first here. You're going to stick with the 1.4 plus. Okay, inside here we're going to multiply before we subtract, so I'll say -15 minus 7. Bringing down the 1.4 again, plus. Okay, negative. Now you'd think you'd take the absolute value of -15 and -7. No, just evaluate them first inside here. This is going to give us the absolute value of -22. Once you get it down to one number, then you take the absolute value of it. So this is 1.4 plus the absolute value of -22 is positive 22. There should be no decimal there. That's just 22. 1.4 and 22 is 23.4. Okay, I'm going to have you guys do this one on your own, this next one over here. The actual answer is -10.8. The interesting thing about this one is there's a negative symbol outside the absolute value. So once you take the absolute value of whatever this is, after evaluating it, it's going to be positive. Well, then you change it to a negative right here. So I'll give you a little hint. And we'll pick the rest of the notes up when we get to class tomorrow. If there's a quiz after this, I'd like you to do that quiz and we'll talk about that. Thanks for paying attention. You're the biz bomb.